look at this figure. Let us take two vectors of magnitude 10 square and 10 raised to 4. What the vector product or the cross product is given by sin theta, right? Here, if you take, in this case, you take 10 squared magnitude, 10 raised to 4 magnitude, and theta is 90, sin 90, let us say. Then this will become 10 raised to 6, right? This is a 10 raised to 6 combined. This. And with this 6, we add another 2, similar way. 10 raised to 2 into 10 raised to 6, another 2 we are taking, then it becomes 10 raised to 8. This is on, let us say, this is totally C. C in the sense, it is the quantum world. In the quantum world, what is C? 3 into 10 raised to 8. Meaning, if you take 3 such 10 raised to 8s, you will get C. That's, I mean, my kind of developing the uh, uh, um, quantum world. And let us now take C itself. C, C squared, similar following similar, taking similar cross product, which is like this is magnetism, this is electricity, this is the thumb gives you the right hand rule, the thumb gives you the field, direction of the field, right? Propagation. So now let us take C, start from C. Basically, we are dividing this into two worlds, quantum and relative, let us say. We take C, C squared, giving C cube, and with C cube we take another C, getting C4, right? So if you take like that, I'm not very really sure about the mathematical implications and feasibility of getting such a uh, product. We can work it out. I think if there is anything wrong, we can work it out. So anyway, so C squared, C cube give you this C cube with along with C gives you C squared, and C4 along with C2 gives C6. Why I am talking about these things? Uh, I always tell you about my chance discovery, which was Planck's constant. How we arrive at Planck's constant? In 1992, I, by chance, of course, found that Planck's constant h equal to 119 times mass proton divided by 3 into 10 raised to 8, which means this is C, This is nothing but the C, and the mass of proton was multiplied by 190. Now let us go to my favorite subject, which is Pascal's time, of course. Let us go to Pascal's triangle, where we can clearly we take Pascal's triangle here. What is Pascal's triangle? Pascal's rule. First of all, let us start with Pascal's rule. What is Pascal's rule? The Pascal's rule gives you the coefficients of binomial expansion. What is the rule? N k, it's represented like this, is equal to n minus 1, k minus 1, plus n minus 1, k plus k. So, what does it mean? If you start with 1, how do you build a Pascal's triangle? You start with 1, put either side zeros, plus plus 0 plus 1. This formula means you have to add subsequent rows, the quantities in the previous row. So 0 plus 1 is 1, 1 plus 0 is 1, here 0 again, 0 plus 1 is 1, 1 plus 1 is 2, here 0 again, 1. Like that, you go on adding the numbers. Next number would be naturally 0 plus 1 is 1, 1 plus 2 is 3, 2 plus 1 is 3. You go on adding like that. That is the Pascal's triangle. Okay? So now, uh, yeah, then what has Pascal's triangle got to do with our C square, C raised to 4 and all that I just now described? 10 raised to 2, 10 raised to 4, 10 raised to 6. Why I took basically 10 raised to 2 will be like 9, 10 raised to 4 will be like square, 10 raised to 6 will be like the surface area of the cube, and 10 raised to no, 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 not that, 10 raised to 8, uh, 10 raised to 6, 10 raised to 2 is yes, there is a square is 10 raised to 4, cube is 10 raised to 6, yes, 10 raised to 6 is the cube. Right? So here we can divide this Pascal's triangle into rows, right? These rows, let us start with, these are basically, as I told you, 1, 1 1 1 2 1 1 3 3 1 1 4 6 4 1 is the Pascal's triangle. In this triangle, these are nothing but 11 raised to 0, 11 raised to 0, 11 raised to 1, 11 raised to 2, 11 raised to 3, 11 raised to 4, like that. So I am taking inverse of that. This is 11 raised to 0 equal to 1. This is this is 11 raised to 1, 11 raised to 2, 11 cube, 11 raised to 4, 11 raised to 5, 11 raised to 6, 11 raised to 7. So last time, what is that I found? I found that uh, if you take 119 times nu, uh, H is equal to 119 times mass of proton by C, right? So this 119 is very close to 11 squared. If you go on, if this number is higher and higher, you just have to less only 2 from 121 to get 119. So this corresponds to this level, meaning 3 into 10 raised to 8. The other meaning of this Planck's constant is that when 119 protons come together, they divide into C number of particles. This is, we can as well write it as 119 m by Planck's constant. So this is nothing but number of particles. If these many number of protons come together, they will divide into C number of particles. So this is the number of particles. Okay, this is the number of particles. So similarly, this is C. Now this will be C squared, this will be C cubed, this will be C raised to 4, C raised to 5, C raised to 6. In terms of C, you can take it like that. And approximately this will be root of C, this will be fourth root of C. So this is the side view, this is the top view, let us say. Let us remove this. Right. This is the top view. Let's see. What will be the top view here? 3 into 10 raised to 8 is electromagnetic radiation. So let's say wave. The layers, the levels will be alternating between particle and wave. Particle is, as I told you, 10 raised to 6 is a particle. If you go higher, uh, 10 raised to 24 will be a particle because you take C square, C cube. C cube is nothing but 27 into 10 raised to 24. This will be, this is a perfect cube. 10 raised to 6 is 10 square whole cube. This is a perfect cube. So they make the waves. That is the wave of particles. And anyway, here, we are losing track of it. Let us not bother about this. We'll come to that later. What happens here is, what happens here is, let us start with this being wave, this being particle, this being wave again. So let us start with a wave is a cube. So This is the fourth root of C. Around that we have a circle or sphere. This is root of C. Above that we have uh, what was that? C. C. Where? Okay. Above that you have after C you have C square. C square, which is a mass, and that I will come to that. Now again you have C cube. C cube again is cube. You have a C4, which is uh, C4 is a sphere, spherical thing. So the whole of physics, the development of physics, evolution of physics, over 400 years, we can represent it here. Galileo started with his basically what do you call this is you can say this is the evolution of physics over 400 years, you can say. Galileo came up with principle principle of equivalence. Then Maxwell came up with uh, equations, Maxwell equations. Second one. Third step was Planck's what do you call quantum. So this I explained earlier. Why 3 into 10 raised to 8? What is 3 into 10 raised to 8? I explained 119 times mass of proton by C. So since it has the term C, it corresponds to this level. So Planck's constant. After that, you can say Newton. When you say E equal to mc square, so what is m? M is equal to E by c square. So if you take c squared, if you take divide energy with c squared, you will get 1 kg of mass. Nothing. This is nothing but mass, right? So c squared represents mass. So Newton's gravity it represents. And again, C3 here we had Kaluja. Kaluja came along, not Kaluja, sorry, no, this Kepler. Kepler. This is Kepler. He dealt with the planets and other bodies which are cubical in the sense they are perfect cubes. And then there came Einstein. Einstein took C4. In fact, Einstein's equation, what is Einstein's equation? G mu is equal to 8 by G by C4 T mu, right? That C4 Einstein mastered. Then came Kaluja. Kaluja introduced the fifth dimension, C5, but he failed in predicting the masses. So we need to tau is at 6 level. So you can say, and the other interesting thing is they found that Maxwell found they found that C is equal to practically epsilon naught mu naught, which is mu naught is 4 pi 10 raised to minus 7 epsilon naught is equal to 8.854 into 10 raised to minus 12. This, if you take product of these two and take a square root and inverse that, you will get C. The square point. So up till here, from here to here, this was quantum world reality. From here to here, it is relative. From here up, it is tau yet to be discovered. So what I say is, you should not limit yourself to the C4. You should again take C5, C5, C6, and another C7, wherein this C7 will be time-like. This whole oh, C6 will be 6 space-like dimensions, right? And uh, yeah, yeah, no, no. Maxwell's equations, which are until here, cover this part, are basically first equation is A equal to rho by mu, rho by epsilon naught. Second equation is B is 0. Third equation is what is the third equation? Cross the curl of E minus rho B by dt. I think. Let me check. Yeah, minus W by dt. And the last equation is curl of magnetic field is given by mu naught into J plus epsilon naught dou E by dou T. Yeah, so all these equations cover the area between root 4C and C. The relativity covers up to this, meaning this C4, wherever the C4 is, this is the C4, this is the fourth root, C square, C cube, C4. Yeah, this is the one. That part is Einstein. What Einstein came up with. This part till here, from here to here, this was Maxwell's part. This border, let us say, the quantum is Planck's. Uh, yeah. So what I mean to say is, though from side view, you cannot make out which is wave and which is particle. Yeah, basically, in the beginning itself, I should have told, I think, but it doesn't matter. Um, how Newton Newton proposed corpuscular theory, which is nothing but he said light consists of particles called corpuscles. Then Huygens came along, said he came up with wave theory. He proved that light behaves like wave. Then again, Young in 1901 came up with his double slit experiment, which what he did was he projected a light from here. He put up a double slit obstacle like a metal plate or something, and here he put a screen. Let's say, bigger. Here, when he switched on this light, made the light pass through this, what happened was they observed streaks like this. Okay, so there were some bright fringes, dark fringes, followed by one bright, like that. There were some alternating fringes. So from that, what they concluded was the light, each each of these uh, particle, they split into acts as a new source of this thing, perturbation, and these waves, which were created by these interaction of these waves, they created these bright fringes, rather dark fringes. Had light been just particle, what should we have? Ideally, what should we have observed? Only two slits. Whatever were here, they should have directly passed through and they should have deposited on the screen. So this definitely did not happen. Means this is a, light is not a particle. I mean, not just a particle. He, it is both wave and particle because it has showed the quality of interference, and because of the interference they had alternating lines of bright and dark. Dark ones are the particles, light ones are because of interference. That is why they concluded forever, for sure, that light is both wave and particle. Right?